Hey boys and girls, it's Mr. Giomini coming to you with a problem we had on homework last night that I've discovered quite a few of us had some difficulty with. So, if I take a look first, let me see if I can get rid of this and move it out of our way for the time being. So I have a football field is 100 yards with 10 yards at each end for the end zones. The field is 45 yards wide. Find the length of the diagonal of the entire field, including the end zone. So, I've actually, instead of drawing a picture, I've actually just copy and pasted one, but I can see the field's 100 yards long, including the end zones are an additional 10. So if I am thinking about this, that means it's 100 yards from here to the front of the end zone, from here to the front of the end zone. So from front end zone to front end zones, it's 100 yards. Now it says each end zone is then an additional 10 yards deep, essentially, or 10 yards long. So now I'm asking myself, how long is the entire field? Well, from here to here it's 100 yards. From here to here it's 10. 10 plus 100 is 110. Add that additional 10. So now I know the whole field is 120 yards long. Now it told me that the field is also 45 yards wide. So I'm just going to draw a little line here. So I know that this side of the field is 120 yards. This width here is 45 yards. Now it told me find the length of the diagonal of the entire field. Now a diagonal goes from one, if I look at this as just a rectangle now, one vertice, which I'll choose here, to a non-adjacent vertice. So that would be all the way down here. So I'm going to make a diagonal going from here to here. So there is my diagonal from one vertice to a non-adjacent. Now if I take a look at this, I've just now made, and I'll highlight it, I have just now constructed a right triangle out of this football field. And we have to figure out what are the high legs, what is the hypotenuse. Now remember, the legs are adjacent to each other and they also have the right angle in between them. So here's my right angle right here. So one leg is 45, the other leg is 120. So I am looking for this diagonal. Now remember, we can always go back to that formula that you can hear a lot about when you get up in the grades with a squared plus b squared equals c squared. A squared plus b squared equals c squared. We could also do leg 1 squared plus leg 2 squared is equal to c squared, or equals c squared, or the hypotenuse squared. So leg 1 is 45 plus the second leg, which is right here, is 120. Now remember, we are squaring these, which are going to give us some biggest numbers, and that's going to give us the hypotenuse squared, or we'll call it c squared. Now I'm going to cheat here, use a calculator. Put in my calculator 45 squared. That gives me 2025 plus 120 squared. 120 to the second power is 1,400, or 14,400, sorry, equals c squared. Well, I have an operation to do over here. I must simplify, so I have to add this. So 2025 plus 14,400, that gives me 16,425. That's going to be equal to my hypotenuse squared. Well, I just want to find out what the hypotenuse is, not the hypotenuse squared, so I'm going to find the square root of both sides. Whatever I do to one side, do the other. Okay, so that just gives me c now. The square root of 16,425, square root of 16,425 gives me 121. And if I want to take this out to the hundredths place, 16 hundredths, and that would be measurement in yards. So hopefully that helps you out. Again, boys and girls, I can't stress enough, make a diagram, make a drawing, especially when it comes to these word problems. It's very difficult to try to just throw numbers down without looking at some kind of visual representation. Hope this helps you. Take care. Bye.